Welcome to 1.06. Just a reminder, make sure that your heading is complete, that you are including the aim in your heading, and that your table of contents is up to date. Be a good thing to make sure is on the right track. All right, let's go ahead and get started. Okay, consider the functions and their graphs below. Make sure these are sketched in your notes, including the functions. Now, it is a mathematical fact that any quadratic equation has two solutions. Now think about what this means. This means that any quadratic function has two roots, since a root is just a solution when you set y equal to 0. All right, so you'd set your y variable equal to 0, solve for x. In other words, you're solving an equation, and you're solving a quadratic equation. It will have two solutions, therefore two roots. How is it possible that function 2 and 3 only appear to have 1 and 0 roots respectively? So remember that the graphical interpretation of a root is where the function intersects the x-axis. So if we notice, function 2 appears to only do that once, and function 3, 0 times. So your goal is to try and figure out how this could be the case. Okay? So I'm telling you, it's a mathematical fact. It's been proven. I can prove it to you. And what you want to do is do some investigating as to how could there be the situation where that you have a mathematical fact that you have two solutions, but when you look at the graph, you only see one or none. So my advice to you is to try finding the roots of these functions. Do some investigating, make sure that you've shown your work and given this a try. Okay, so hopefully you were able to do some investigating on your own and you have some idea of why this situation is coming up. First, let's take a look at the normal situation where we're very confident that there are two solutions and then also two roots. So to find the roots, I'm going to set my y value equal to 0 and solve for x. And I can use the quadratic formula to do so. And here's my work. And we'll notice that I have 4 plus 12 inside my square root. And so that is 16, and I'll just make note of that there. That is 16, so we have 2 plus or minus the square root of 16. Well, that's 4, right? So now I have 2 plus or minus 4 over 2. So let's take care of the first option. 2 plus 4 is 6 over 2 is 3. 2 minus 4 is negative 2 over 2 is negative 1. And if I look, there are my roots. Okay, now let's take a look at number 2. If you struggled with these the first time around, if the first one gave you a little hint, now go ahead and pause and try this again on your own. All right, so now looking at number 2, same idea for finding the roots. I'm going to set the y value equal to 0 and solve for x. And using the quadratic formula, I get 6 plus or minus the square root of negative 6 squared, which is 36, minus 4 times 9 times 1, which is 36 over 2. Now let's go ahead and evaluate this. What's 36 minus 36? That is 0, right? Okay, what's the square root of 0? Well, 0, right? 0 times 0 is 0. So now I have 6 plus 0 over 2, which is 3, and 6 minus 0 over 2, which is 3. And that seems weird, right? Like they're the same thing, so how is it that you could have two solutions? Well, what we say here is that there are two solutions, they just happen to be the same, so they're repeated. Now, one way to understand how this comes about is to factor this. And so if we were to factor this, we would get, and I'm just going to do this down here, x minus 3 times x minus 3 equals 0. Okay, but we can simplify this further. X minus 3 is the same as x minus 3. So you're multiplying something by itself. So this is really x minus 3 squared equals 0. And this helps you see that this root of 3 shows up twice in the function. It's called a root of multiplicity 2. We'll talk about that a little later on. Or in this case, one solution that is repeated twice. Okay? So we see that, look, the mathematical fact still holds. There are still two possible solutions. They just happen to be the same because each of the factors is identical. So it provides us with the same value, 3, that makes the function equal to 0. Okay, let's move on to number 3. All right, so what I've done is gone through the first steps of number 3, and I have the same setup. I'm using the quadratic formula to solve for x. -3 plus or minus the square root of 3 squared is 9. 4 times 3 is 12, times 1 is 12, so 9 minus 12. Okay, so let's rewrite with the next step here. I have -3 plus or minus the square root. Now 9 minus 12 is -3 over 2. So in order for us to evaluate this, we need to figure out what the square root of -3 is. And to help us do that, I want you to try a slightly different example. Try the square root of -9. See if you can figure out what that would be. Well, if you try a couple things, you might try -3, for example. Well, the square root means you're finding a number that you can multiply by itself to get the number inside. So if you said -3 was correct, try multiplying -3 by itself, and you'll get +9. So -3 isn't the square root of -9. What about +3? Well, certainly that's not correct because 3 times 3 is +9. So what we're seeing is that with the numbers that we currently know, there is no way to get the square root of a negative number. And a square root of a negative number is what we call an imaginary number. And we're going to talk about imaginary numbers in much greater detail coming up. The square root of a negative number is an imaginary number. That is an important thing to remember. And an imaginary number, when combined with real numbers, so for example, -3 and 2, those are numbers that we know, right? Well, when we combine them together, when we have something that's real and something that's imaginary, we call that a complex number. Okay, so we don't know much about imaginary numbers right now, but let's just leave this the way it is. We'll tackle imaginary numbers soon, and let's make sure that we still have 2 solutions, even though it includes an imaginary number that we haven't quite defined yet. And to make this really clear, what I want you guys to remember is that if you have something plus something divided by 2, you can divide each by 2 separately and then add. I'll give you an example to illustrate this. If I have 4 plus 6 divided by 2, that is the same as 4 divided by 2 plus 6 divided by 2. And you can check this. So 4 plus 6 is 10, over 2 is 5, and 4 over 2 is 2, 6 over 2 is 3, 2 plus 3 is 5. Another way to make sure that this is correct is notice that these have a common denominator, so you're adding the numerators and keeping the denominator the same, which is exactly what we've done here. So we're going to rewrite this solution as x equals -3 over 2 plus or minus, we're going to do both, of the square root of -3 also over 2. Now remember, this part here is still imaginary. I'll use IM for imaginary. And this solution here, this whole thing, is still complex. I'll use C for complex, or CX for complex. And so what we see here is that even though we have this imaginary piece, there are still 2 possibilities. I have some value, -3 over 2. I can either add this imaginary piece or I can subtract it. So I still have 2 solutions. It just turns out that these are not real numbers. And I can look at my graph and say, hey, they certainly aren't, because if they were real numbers, they would show up somewhere. But they're not. They live somewhere else, and so they're called complex solutions. All right, at this point, what we want to do is try and figure out why this happened. So pause the video and take 10 seconds to go back over the work and see if you can spot the point in time where you should have been able to tell which type of solution we were going to get. Hopefully you noticed that the key to figuring out whether we were going to have 2 different solutions, 1 repeated solution or 2 complex solutions, was whether we had a positive, a 0, or a negative inside of our radical inside of the square root. And this is called the discriminant. Right? The discriminant is the value that's inside of our square root in our quadratic formula. It's the b squared minus 4ac part. And so based on the value of our discriminant, we should be able to tell ahead of time what type of solutions or what type of roots we're going to have for our quadratic functions. So let's go ahead and make sure we have this information down. Okay, so here I've written again the definition for the discriminant. The discriminant is just the value inside the square root. In other words, it's the value of b squared minus 4ac. And so depending on the discriminant, we have three different types of roots or solutions. So what I'd like you to do is go ahead, copy these down, see if you can recall which situation will be the case if we have two, one repeated, or complex roots, and then we'll quickly go ahead and go over them. Okay, so hopefully you realize that if the discriminant is positive, we'll have two different solutions, or two real roots. If the discriminant is 0, then we'll have one repeated real root, and real just means it's a real number that we are used to working with. And if the discriminant is negative, then it will have two different solutions that contain an imaginary number. Or, in other words, that if it contains an imaginary number, that's what's called a complex number. Okay? Now, we're going to rewrite these situations in a way that's really mathematically sound. So the discriminant is the value of b squared minus 4ac. So let's just write this here. B squared minus 4ac times c. And if this is positive, that means that it's going to be greater than 0. So if you have a situation where b squared minus 4ac is greater than 0, you will have two real roots. Let's do the same here. The discriminant is b squared minus 4ac. Okay? If it is equal to 0, so we just represent that as equal to 0, then it will have one repeated root. And here, if the discriminant is negative, meaning if b squared minus 4 times a times c is less than 0, then we will have two different complex roots, or complex solutions. And we can see what the graphs of these situations will look like, right? So function 1 is an example of two real roots. Function 2 is an example of one repeated root. And function 3 is an example of complex roots. And so it's important to note with complex roots, these numbers, these complex numbers, aren't on our xy axis. So there's nowhere on the x-axis that you have a complex number. And so there's nowhere on the x-axis that your function is going to intersect it. All right, so go ahead and copy down each question. Make sure you have the question down. And your solution to each of them. You need to have a worked out solution. None of these are things that we haven't just done previously. So go ahead and give each of these a solid try, and then tomorrow you'll be able to check your work with your fellow classmates.